Hello, this is for digital check-in number 2 for calculus. This time I've tried to do something a little bit different in that I did the questions before I started the video, which I am now recording. So let's hop into it. In the first question, which I did myself, this part is correct in that this is the related rules equation. This part, the math checks out here. However, this is where whomever wrote this went wrong, in that they assumed that this was a negative number because it was falling away, but because that is a negative, that means that this number would be decreasing towards the right, which would be making this smaller. But in this instance, just because x is negative, or just because the value is negative because we associate west with left, that's not actually the case. In fact, the graph of this should probably, if he was for just simplicity, should be flipped. That, like, this D should be over here in this manner to make a triangle this way to truly get at what it is, because the question is basically these two ships are moving further apart. So what is the average rate of change of D when ship A, which is Z, 50 kilometers away, and X, which makes ship B or X 30 kilometers away from port? But because they have a rate of change of 9 kilometers an hour, because they assume west, they get an erroneous number, which is 8.23 kilometers per hour for the change of D. D is not actually changing. That isn't right, because that would basically make this equation 2x to the derivative of x plus, or actually it would make it negative 2z to the derivative of times the derivative of z equals, well, etc. But knowing that the negative 9 is where they went wrong, as a concept, I would say that they do understand it. However, they need to understand that just because graphically the ship is moving this way, it does not mean that this is a negative relationship. The actual rate of change for D should have come out to around that at 50 kilometers, at the moment that this ship A crossed 50 kilometers an hour, or sorry, 50 kilometers, the rate of change at D for that time is 17.49 kilometers per hour, or that's how far ship A and B are getting apart from each other at the time that ship A reached 50 kilometers from their origin. All right. Now, explain the function AX. What are its inputs? What are its outputs? Why is it shaped the way it is? So we have the function X here, but I don't know why we have this top one, because this top one, oh, it does do something. Okay. One, I want to say this was an unfair question. In fact, the next one and this one were an unfair question, because at the time of this, we haven't actually gotten to integers. That's actually the next segment, because we stop at 5.1, which is God, what was it? 5.1. Summations, right? Summations. So we haven't actually gotten integers yet, but saying that, A is the verticality of this graph, and when taking an integer, it's basically asking what's the shaded area underneath the equation for integration. Like, what is the area here and here? For the input for A would be the leftmost, where we would start integration here, and then the x on top would be where we would where we would end the integration on the right side. So by changing this, we are basically saying, by changing any value here, especially A, we're changing where the integration starts, or yeah, where it starts. So that the greater the A, the more we would integrate below this line. And for f of t right here, it's basically saying what's the integration of this top equation here. In fact, if I change this equation like so, let's get rid of, it changes the entire equation because we're actually integrating based off of this, and we're taking this derivative, the derivative of this, and then integrating it. Okay, that's the best I can describe it at this time, because once again, integration at the time that this was asked for was the next lesson. So, that being said, find the difference between two integrations. Now, if we take the summation of, the sum of two integrations, we get something along the lines of, well, let me go back to this one. Is there a draw tool? No draw tool. Oh no, I'll just do paint. All right. And, all right, there we go. And if we have, let's call this, let's make this a little bit larger too. All right, so let's call this f of x. Terrible f of x. I know. I don't have a lot of experience drawing. Let's call this g of x, or g of plus rather. So when we combine these two, we get something like this. We take if this was a, and this was b, or oh, that's a d. And so we take A, B. Basically it comes down to when we combine integers, we ask we take the difference between point A and then add it to the comparison here of A. So if whatever this value here is, distance is, we add to this side, which let's say it's here, and let's say this is obviously the smallest, so we'll just put something like here, and finally B, it goes up, so we get something along the lines of that when we combine the two terms. But it's asking, for integration, it is asking what is the area under this, which doesn't really change when you combine integrations, but you have to show it. However, when you subtract integrations, the reverse is true, where this would appear one under the other. So let's bring that back up and go to the next slide, which I already prepared. So if we take g of x, which is the first term, which is in black, and subtract it by the red one, we get basically this, so that everything under the blue is what we would now integrate. Actually, second thought, we wouldn't really integrate this because it's not under g of x, and we wouldn't really integrate that either. So basically, we're left with this Everest-looking peak, nice little mountains here, as to the area that we integrate when we take these two formulas. And this comes out to something like 17.48. Anyway, I hope this was found informative. Thank you for your time. I will be talking to you in the... Actually, I'm not sure if I will be talking to you. But anyway, have a nice evening or day when you view this. Goodbye.